following. Electrolysis occurs when an external electrical potential is used to cause a non-spontaneous redox reaction to occur. This is the process in electrolytic cells. So if you were to take a look at your phone, right now, the battery inside your phone is giving off an electric current that is allowing your phone to work. But what do you do at the end of the day?
Charge it.
You charge it. So you take your charger and then you stick it in. And you're basically reloading up your battery, isn't it? When it's now charging, that's when it's an electrolytic cell. Because a phone does not charge by itself. So if we were to take a look at the situation here, remember yesterday when you guys let your physics teacher down and did not know how the electrons flow out of a battery? So we have the battery over here, and you have your negative and you have your positive. A battery will spontaneously send out the electrons and it will go in this pathway. This is when we have an electrochemical cell. Now when we plug it in to an outlet and we charge it, ultimately what we're doing is we're forcing the electrons to go the reverse direction. That's when you have an electrolytic cell. Okay? So essentially, an electrolytic cell is using an external power source to force the electrons to go in reverse. So, when we take a look at these next points, these are the things that you need to make sure you keep straight in your head. So the process occurs in this process occurs in electrolytic cells. So some points. Oxidation still occurs at the anode. Point number 1. Point number 2. Reduction still takes place at the cathode. But now here is something a little bit different. The signs are reversed. So number 4. Cations still move towards the cathode. Number 5. Anions still move towards the anode. Number 6. The negative side, the anode of the power supply, is connected to the cathode of the electrolytic cell. And number 7. The positive side, or the cathode, of the power supply is connected to the anode of the electrolytic cell. Now, there's a lot of little bits and pieces in here. And again, it will not make sense until you see the whole system. So, put your pens and pencils down. Now, I'm going to draw the diagram and I'm going to show you how an electrolytic cell works. Sorry. So the first thing that I'm going to draw is I'm going to draw 2 electrodes right over here. 1 and 2. And they are in this container. So first and foremost, what do you notice is different about my setup?
They're in one container. They're in one thing.
They're in the same liquid.
Yes.
They're in the same beaker.
Mm-hmm.
Now, the next thing that I want to say is that this here is an electrode. Okay, typically we have it as an inert electrode, and if it's an inert electrode, it's either carbon or platinum for chemistry 12 purposes. Okay, you will never handle platinum electrodes in this course. Too expensive. This one is also an electrode. And for the time being, it is inert. So it is made from carbon and platinum. Now, do you notice that I have not said whether it was a cathode or an anode? Do you guys see that? Because it will not be determined until I hook it up to a power supply. So up here, I'm going to have a power supply. And this one here is going to be your electrochemical cell. And I'm going to hook it up like this and hook it up like this. Do you guys see that? So can I get you right now to just draw that for the time being?
Can you do the drawing for me? I don't have paper to draw it on.
I'll just draw on this and just take a screenshot and send it to you.
Thank you. And then it goes.
Okay. Which copy? Now, if we learned about the power supply and it's an electrochemical cell, we know that there is going to be an oxidation and a reduction on the electrochemical cell. Do you guys remember that from yesterday? So, whichever side, it's basically the choice. So I'm going to make this left side the oxidation side, and this side over here, the reduction side. So for the electrochemical cell, for the side that oxidizes, what do we call that side? What do we call the electrode on that side? This is the anode side. Reduction, this is the cathode side. So we're still talking about the electrochemical cell. Now, based on what we learned yesterday, the electrons are supposed to come out of which side of the power supply? The anode side. So in this case, the electrodes are coming out. Do you guys see that? And the electrodes the electrons are supposed to be going in on the other side. So far, so good? Okay. Now, in the solution, what we would have is we would have our ions. We would have either our positive or our negative ions. So now, let's see what happens. We're going to focus in on the oxidation side first. The electrons are going to travel down the wire, and it's now going to fill up this electrode. Do you see that? Now I want you to think about what happens here. When the electrons fill up the electrodes, it has a lot of electrons that it wants to basically give away. Or you can say that electrode is full of negative charges. If it's full of negative charges, which ion is going to be attracted to this electrode? If this is full of negative electrons, which ion is going to be attracted to this electrode? The cations, the positive ions. So at this point in time, the positive ions go here. Now I want you to think about this. The ions are missing electrons. It's going to an electrode that's full of electrons. What's going to happen to that positive ion? It's going to gain electrons. If it gains electron, what process is that? It's reduction. So therefore, reduction happens over here, doesn't it? And if reduction happens over there, what do we call that electrode? An aux paired. What do you call the electrode where reduction takes place? Cathode. So do you see the following? Do you see over here? And I'm going to highlight this in yellow. The cations move towards the cathode. Do we have the cations moving towards the cathode? Yes. We also have reduction takes place at the cathode. Does reduction take place at the cathode? Okay? So, that's the first side. Now, let's take a look at the other side. So the electrons are being pumped through this wire and into the battery. So it's being removed from this electrode, isn't it? So therefore, what charge is now on this electrode if it's losing electrons? It's positive. So over here, this is all positive right here. Okay? It is lacking in electrons. So if it has a positive charge, which ion is it going to attract? The negative ion, which we call the anion. So if the anion goes to this side, and the anion has extra electrons, and it goes to an electrode that doesn't have enough, what's going to happen to the anion? It will give it away. It will lose. And the process of losing is oxidation. So oxidation happens here. What do we call the electrode where oxidation takes place? Anode. Thank you. Now, let's take a look. I'm going to use pink here. So, anions move towards anode. Did the anion move towards the anode? Yes. Oxidation takes place at the anode. What happened over here? Oxidation took place. You guys see that? Now, notice over here, number 6. The negative side of the anode of the power supply is connected to the cathode. So, in this case, the anode of the electrochemical cell is connected to the cathode. So if I take a look over here, do you see the anode is connected to the cathode? Then over here, the positive side of the power supply, the cathode, is connected to the anode. So do you see the cathode is connected to the anode? Now the final thing is the signs are reversed. So do you see how this end of the power supply, the oxidation, it's giving out electrons, so it's got a minus sign. Remember that from yesterday? Now, if I was to take a look, I'm going to use purple. The oxidation side, which is the anode, is negative. The oxidation side of the anode, what charge is on it? Positive. So do you see how they're opposite? Now, if I take a look at the reduction, which is the cathode on the electrochemical cell, is given a plus sign. What do you have for the red cathode on the electrolytic cell? It's the minus. Okay, you might want to copy the rest of this down. Do you need to write a few things to yourselves?
Yeah. It does have that. Crazy facial.
So some things that would be really key is if you were to try to redraw this, would you be able to explain all of these processes? And a hint to you is it will always start at the electrochemical cell. Because if I was to flip this electrochemical cell over, then all of this part of the electrolytic will also be flipped over. So right now I'm giving you guys some time. So I'm just copying it, you look at it, can you actually identify these 7 points?
Can you send it?
There's what?
Go to the washroom. Can you make sure?
Is it an emergency or is it like you just wanting to walk? Okay, take the sign. Is this making sense? If you
It's getting
drew
there.
this Chen, it makes sense. If I had to draw it, it won't make sense. Okay. So with this in mind, we have all of these setups. So you should be able to now sort of take a look and see this one here, and then be able to apply that to this diagram and say, oh yeah, they are one and the same. Now, what we're going to do is we're going to finish off today, and what's going to happen is I'm just going to start with this first example, which is an application of electrolytic cell. Okay? Now, in terms of where this is concerned, what we typically use electrolysis for is for the purification of substances. Now, when you guys are taking a look, I will skip over number 1. I'm going to take a look at number 2. General rule of thumb is you maximize positive voltages and minimize negative voltages. And as we do more examples, you see why. So over here, you have an electrolysis of molten magnesium chloride. Now here are some key words that you guys need to make a note of. And the first key word here is molten. Okay? So in terms of where this is concerned, where it is now molten, you're thinking, oh, molten means liquid. Now, when you guys are taking a look at this, you have to differentiate between two states that gives you something liquid. The first one here is MgCl2 liquid. The other one here is MgCl2 aqueous. So what's the difference? Are both of them in liquid state? Yes. But how is one different from the other? Right. So this one, the aqueous, the ions are suspended in water. It is not melted, it's dissolved. This one is dealing with a solution. This one is dealing with a pure substance. So here, when we're taking a look at molten, it is a pure substance. So you might want to write this down. It is melted. So this is something that is happening in a very high temperature furnace. Now, the second thing that you want to see is, if in grade 12 we say platinum electrode, your assumption is that your electrodes are going to be inert. So there are two elements here, carbon and platinum, that is going to be considered inert in chemistry 12. Okay? So this means that whatever these electrodes are made of, they will not be part of your reaction. So the whole idea here is the following. So the following questions will be asked is, what reaction is taking place at the anode or the cathode? What voltage is required? So in this case, if you were to take a look, do you see the power source? Do you see one side is negative, right over here? One side is positive. Do you guys see that? So right off the bat, what direction is the electrons flowing in? So I'm going to have electrode A and B. So the electrons are flowing into what and flowing out of what electrode? So the electrons are going out of B, going through the battery because the battery is a pump, and it's going into A. So right off the bat, you know that this one is going to be filled with electrons. This one is now going to be lacking in electrons. What does that tell you about the identity of electrode A? What is it going to do? To whatever comes its way. Reduce. So if this is now going to reduce because it's full of electrons, what type of electrode is this? An aux carrier. What electrode? It's the cathode. Thank you. So this one obviously is going to be oxidation. So what electrode is the one on the right? It's the anode. So notice over here that these are made from exactly the same materials, but one is going to be a cathode, one is going to be an anode, Because of the power source. So the power source drives the electrons, which is going to control the reactions happening in each of those electrodes. Now in this case over here, this is now molten MgCl2. So I've got Mg2 plus here, Cl minus here. Do you guys see that? So at this point, I want to see what reaction is taking place. So I'm going to go and I'm going to take a look here. And I'm going to clean this up a little bit. And if you guys take a look at the very top, do you guys see over here that I have my Cl, which is right here? Do you guys see the Cl? And it is a plus 1.36. Down at the bottom over here, erase that, I have my Mg, 2 electrons, and it is negative 2.37. So I'm just going to rewrite it in my example over on the side, just simply because it's just going to be easier for me to work with. So over here, I have my Cl2 plus 2 electrons, giving me 2 Cl minus, and my E naught over here is going to be positive 1.36 volts. And then I'm going to have my Mg2 plus 2 electrons, giving me Mg, and my E naught over here is negative 2.37. Now, here is where things differ. When you guys did the electrochemical cell, you guys did the downhill, didn't you? And as a result, the top reaction went forward, the reverse reaction went backwards. But remember in what we just looked at in our notes in the previous page, or not, in this part over here, remember over here at the very top, what type of reaction am I looking at? I am looking at a non-spontaneous. So if I'm looking at a non-spontaneous, am I looking at a, where's my question here? Am I looking at a downhill reaction? No, I'm not. I am looking for an uphill reaction, this and this uphill. That means that this bottom reaction is now going to go forward, and the top reaction is now going to go backwards. The forward reaction here is reduction. The top reaction here is oxidation. Do you guys see that? So what this means is that if I have the Mg, it is now going to go towards the cathode because the Mg is the cation, isn't it? And so in this case over here, if I take a look, the Mg2 plus 2 electrons is going to go over to the cathode to become Mg solid, and my E naught over here is negative 2.37 volts. Okay? This is the reaction at the cathode because that's the reduction, right? Same thing as with electrochemical. So if you take a look at the oxidation, this is now going to happen at the anode, isn't it? But what do I need to do with this reaction? I need to flip it. So now what I have to do up here is I'm now going to have 2 Cl minus in equilibrium with Cl2 gas plus 2 electrons, and my E naught over here, when I flip it, what do I need to do to this number? I have to make it negative. So this is now negative 1.36 volts. So now if I was to add this up, do you see how the 2 electrons cross out? Now I'm going to get Mg2 plus 2Cl minus to give me Mg solid plus Cl2 gas. And my E naught over here is negative 3.73 volts. So now what does this mean? First of all, do you see this 3.73 volts? That means my power source here has to provide at least 3.73 volts in order to get this reaction to take place. Anything less will not work. Now the second thing is, if I take a look here at the cathode, the magnesium ion is turning into magnesium solid. Do you guys see that? So if I take a look at my picture here, my cathode is now going to get lots and lots of magnesium building up. Does that make sense? Now, let's take a look at what's happening at the anode. What is happening at the anode? The chloride ions is turning into chlorine gas. So therefore, when I take a look at this electrode, do I see things building up on this electrode? No. I am now going to see bubbles here. So if I got you guys to do this lab in this classroom, you'd be getting pure magnesium on one electrode, and you will be releasing toxic chlorine gas and dying. Don't you love chemistry? Okay? So with respect to this, what I'm getting you guys to look at is there are processes here that look the same, yes? But the outcome is going to be slightly different. Now, I'm going to get you guys to continue working on your electrochemical cell worksheet that I gave you guys yesterday. And then tomorrow, what will happen is as follows. Number one is I'm going to finish the other variations of electrolytic cells. And then what you guys are going to do is you will build or analyze the electrolytic cells found on lab number 16. Now, I'm going to say to you guys, make sure you read this through because you have the potential of electrocuting yourself tomorrow. Or Thursday. So with regards to this, make sure you guys read through this so that you guys know what you're doing. Do you need a pre-lab? No. And the reason is because at this point, this is not so much as a skill base, but that you guys kind of are able to see what's going on in your system. But if you guys just come and you guys don't know what you're doing, you will have a very high chance of actually giving yourself a really bad shock. Therefore, read the lab. Okay? So right now it's about 3:01. So I suggest that you guys work on the electrochemical cells and then make sure that you guys have a good grasp of it in preparation for your quiz. And then if you guys have just taken all of these notes and go, I have no clue what Ms. Chan just said, do not say Ms. Chan is a crappy teacher. It is your responsibility to figure it out. Okay, go.